Hello all, welcome back to my YouTube channel all about VLSI. In this particular session, we are going to start with discussion of different kind of instructions which are present in our RISC-V. So in this particular session, we are going to focus mainly upon R-type instructions. Now, this R stands for register to register operations. So this kind of instructions are going to deal with only register kind of instructions. Now, what is that exactly we are going to cover in this particular session is we are going to discuss what is an R type instruction and how this is basically encoded and what is the meaning of each and every particular field, and we are going to discuss each and every particular field, and we are going to discuss what are the different kind of 10 arithmetic RV32 instructions, logical instructions we have, and we are going to discuss the difference between addition and subtraction in our R type instructions. And yeah, we are going to see one example and all right now. So first of all, before going to start with this, we need to understand what do you mean by an instruction. So basically an instruction is the fundamental unit of a work of work a particular cpu is going to execute. So in our previous sessions we have seen that whenever we are going to write a particular C language code, that will be converted into an assembly language, and that particular assembly language is basically converted into binary format, right? Now in the assembly level language it is going to form a particular instruction. Okay, so basically instruction is nothing but it's kind of a command. You're going to instruct your cpu like what to do with a particular data or what kind of operation a cpu should do. That is nothing but my instruction. Okay, so basically it is a binary encoded command fetched from the memory, that is from im instruction memory, one at a time, and that is going to tell the CPU precisely what operation to perform. Okay, so it is going to specify the operation like the opcode, and we are going to have something known as function and all that we are going to see in great detail. And it is also going to specify the operands like which particular register the data is present and where to store and which particular memory address it should refer to, and what are the immediate values if we are dealing with immediate instructions and all. And in RV32I, every particular instruction is of exactly 32 bits width regardless of its format. So basically we are going to have different kind of instructions. I will let you know what kind of instructions and all, but whatever it may be, your instruction size will be of only 32-bit width, and this particular instruction is stored in instruction memory and fetched at the address held in the program counter. This is what we have also discussed in our previous sessions. Now, so basically coming to this R type instruction are going to look like this. For example, add x5, x6 and x7. So what is that we are going to do? We are going to add x6 and x7, and the resultant will be stored in x5. This is nothing but my R type instruction. Now, how can I basically find it out? It is an R type instruction because you can see x5, x6 and x7 are all the registers. I'm basically performing the addition between only the registers. That's the reason it's an R type instruction. Okay, now so basically R type instruction, it's a register type, is one of the 6 base instructions in RV32I, and it encodes operations that read two source registers, compute a result, and write it into a destination register with no intermediate values at all. So this is nothing but my R type instruction. And where it is being used, so it is used for a pure register to register ALU operations like addition operation, or it may be a subtraction operation, or it may be a shift operation and bitwise operation. So every R type instruction is exactly 32 bits width. So both operands rs1 and rs2, that is nothing but my source 1 and source 2, comes from the register file and never comes from the instruction itself. And contrast with the I type instruction. So you can see in this particular, this is nothing but my instruction. I'm telling the processor to add this two source register, the contents which are present in this two registers, and store it in the destination register, which is nothing but my x5. So this is, I'm not specifying what is the value, I'm just specifying which particular register the value is present, so that my processor is going to look into those particular registers, and after performing the addition it is going to store the result into whatever the register we have specified over here, and we are not going to have any immediate value which is present in the instruction itself. Now if I am going to write down add x5, x6, x7, my processor is not going to understand it. My assembler is going to convert this particular instruction into a binary format, And how the binary format is going to look like, let us try to understand. So basically, whatever the instruction we are talking about in R-type instruction, that will be categorized into these fields. So first one is function 7, RS2, RS1, function 3, RD, and opcode. So these are the fields which my 32-bit instruction is basically divided into. So whatever the instruction we are writing, right, add x5, x6, x7, this will be converted into 32-bit format, where this particular 32-bit format is going to have these fields like opcode, RD, function 3, RS1, RS2, and function 7, and where RS1 and RS2 is my source register addresses. Okay, these are my source registers. This is not the actual data. This is nothing but the register where the actual data is present. We are referring to X5. So here the processor will go and it is going to fetch the data, and X6 the processor is going to go and it is going to fetch the data. Like this, your processor is going to basically go and fetch the data. So this bit patterns are register indices, and this RS1 is of 5 bits and this RS2 is of also 5 bits. And RS1 and RS2 and RD are not going to carry the data in the instruction. We are not specifying the data in the instruction. This is very, very important point. They are basically carrying the addresses in the 32 entry in the 32 entry register file, and the same encoder instruction can produce different results on different runs. So because the register content change even though the address in the instruction stay fixed. So this is what my R type instruction is going to look like. So coming to the bit encoding layout. So first of all, I'm going to have 0 to 7, which is my opcode, 6 down to 0, which is nothing but my opcode. Next is 7 down to 11 is my RD. This is nothing but my destination register, like where exactly my result should be placed. That is nothing but my destination register. Next is function 3. So we will discuss what is exactly function 3 and what it is exactly telling us. And this is nothing but my source register 1 and source register 2. Like whatever we have mentioned over here, right? So x6 is nothing but my source register 1, and x7 is nothing but my source register 2. So here I'm mentioning this is of 5 bits and this is of 5 bits. And next is function 7. So what do I mean by function 7? I will let you know in the upcoming slides. So basically function 7, here it of 7 bits, rs2 rs1 is of only 5 bits, and function 3 is of 3 bits, and destination register is of 5 bits, and opcode is of 7 bits. So basically, here for this entire R-type registers, we are going to have an opcode is fixed. So this is the opcode for my all R-type instructions. Okay. So depending upon this opcode only, we are going to decide whether it is an R-type instruction or whether it is an I-type instruction and all. Okay. Now, so let us try to have a look into it. So I'm going to have something known as opcode. So opcode is basically 6 down to 0. This opcode is going to tell me, like you can see over here, this is nothing but my opcode field. So depending upon my opcode only, I'm going to differentiate whether it is an R type instruction or whether it is an I type instruction, or whether whatever the instruction it may be. So how to differentiate between the different kind of instructions in our RISC-V, we are going to decide it by referring to this opcode field. So it is going to identify the instruction family, and it is always 0110011 for R type instructions, and which is of 7 bits width. And next is destination register. So this particular destination register is basically of 5 bit width, and this is going to store the resultant of whatever the operation which we had, and that will be stored inside my destination register, that is this particular field. Next is function 3. So basically function 3 is kind of a minor opcode, and it basically narrows down the operation within R type family. So in R type only we have different kind of operations. So like what kind of operations we are going to have, I will show you in this particular slide. So this function 3 is going to work with respect to function 7. Depending upon function 7 and function 3 only, we are going to decide what kind of operation we are going to do. And RS1 and RS2 just now I've explained. So these are the different kind of fields I'm going to have. Next, let us try to understand what are the different kind of operations which are possible in our R type instruction. So first one is addition operation. So if I want to perform addition operation, then my opcode, first of all, if I want to perform register addition operation, R type instruction, then opcode should be this value, that is 0110011. Next, if I want to perform addition operation, my function 7 should be this value and function 3 should be this value. That means I'm going to perform addition between my two source registers, and the resultant will be stored inside my destination register. Next is subtraction operation. So subtraction operation, my function 7 is this, but function 3 is the same. So here my function 7 is helping me to differentiate between a addition operation and subtraction operation, because function 3 is same for both. Okay. Now coming to my shift left logical, this is nothing but the function 7 is this, and function 3 is this. So I'm going to perform shift left logical. And next is I'm going to basically perform SLT operation, and next is I'm going to have SLTU, and next is XOR and SRL, shift right, and OR and AND. So like this, I'm going to have, and SLT basically stands for set less than, and SLTU basically stands for set less than unsigned. So basically, depending upon whatever the function 7 and function 3, I'm going to decide what kind of operation I'm going to perform between the two source registers, and the resultant will be stored inside my destination register. And this is very, very important to understand. So using this only, we are going to implement our arithmetic logic unit. Depending upon this function 7 and function 3 only, we are going to decide what kind of operation we should perform in the arithmetic logic unit, right? Next. So suppose if I'm going to have my addition operation, just now I told you, right? Depending how I'm going to differentiate between addition operation and subtraction operation is using my function 7 only, I'm going to differentiate between this. Now, for example, if I want to perform add x5, x6, x7, this is my instruction which I'm going to have. Now, how this will be converted into binary format? First of all, my opcode. This is opcode which is fixed for every R-type instruction. And next is destination register, which is 00101, which is nothing but my x5. So I'm basically mentioning x5 in binary, that is my destination address. Next is function 3. Function 3 should be equal to 000 because it's an addition operation, because the function 3 will be equal to 000. And RS1. RS1 is nothing but my source register 1 address, and RS2 is nothing but my source register 2 address, and function 7 is all zeros. That means I'm going to perform an addition. So this is how my binary instruction is going to look like. This instruction will be present inside my instruction memory, and I'm going to fetch it from the instruction memory, and I'm going to decode it, and I'm going to decide what kind of operation I need to perform by referring to this particular instruction. So this is how we are going to understand and decode our R-type instruction. Now, so that is what I was saying about. I'm going to fetch it, I'm going to decode it, and I'm going to perform this reg underscore read and next execution and write back. This we will see like how exactly we are going to perform. And so in this particular session, we have discussed about what is meant by an R-type instruction, what are the different kind of fields, and what is function 3 and function 7, and what are the different kind of instructions in RV32, and how function 7 is helping us to differentiate between addition, subtraction, and shift right or shift right arithmetic, and where we have seen about all these particular things. Yes. So that's about this particular session. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.